For most of our human history, we have been engineering and building stuff with what we are able to see in our everyday lives. But the fascinating thing is that this is going to change drastically as we have started to do engineering literally on the scale of atoms and molecules, by moving them around and trying to get something useful out of them. This type of engineering is called nanotechnology, but what are the advantages of working in such small dimensions, and how do we do that? Let me introduce you to the nanoscale. The place where size actually matters and where being small is actually the best thing that can happen. Technically, nanotechnology is the manipulation of matter on the nanoscale. Nanotechnology is not something new. It was used unknowingly since ancient times. The Romans used nanoparticles in the Lycurgus cup, which basically shows different colors when light passes through it in different directions. And similar effects were also observed in old church windows. All of this was done unknowingly, but now we're intentionally trying to manipulate them. Most of us would have come to know about nanotechnology from Iron Man. The nanotech armor that we saw is actually an interesting futuristic aspect of nanotechnology. There are some far-fetched concerns that in the future, tiny nanorobots might get out of control and eventually take over the world. This fictional incident is called Grey Goo, but more on that later. So what is the nanoscale and how small is it? In our everyday life, we see things in the range of meters and kilometers. If we zoom in a bit, we'll reach the scale of millimeters. If we go even more, we'll have micrometers. Even more, and we'll reach the size of my self-confidence. And if we zoom even more, then we'll finally reach the nanoscale. This is the scale of groups of atoms and molecules. Generally, nanoscale is in the range of 1 to 100 nanometers. 1 nanometer is 1 billionth of a meter. To understand how small that is, let us look at some interesting analogies of how 1 meter differs from 1 nanometer. If you're a billionaire like Elon, and $1 billion would be a meter and $1 would be a nanometer. Okay, that was obvious. Next, if we assume the size of Earth to be 1 meter, then 1 nanometer would be the size of my PP, and PP stands for ping pong ball. If you were thinking of something else, you have issues. So what's the big deal about this nanoscale anyway, right? Why are people getting so hyped? Turns out that materials in the nanoscale have some very weird and unique properties. They completely lose their shape. Everything changes here. Materials which do not conduct electricity start conducting in the nanoscale. Their optical activity changes, melting point, magnetic permeability, everything. For instance, aluminium, which is generally quite stable and used in juice cans, can be reactive and even explosive in the nanoscale. I don't know about you, but I think that's quite awesome, because if you think about it, you're not changing the chemical composition or the crystal structure of the substance. We're just working with it in much smaller pieces. So suddenly their behavior changes significantly when they go from their bulk form to the nanoscale form. Kind of like how my behavior changes when I am around with my family and then with my friends. Moving on, another reason why the nanoscale is so special is because most of our biological processes happen at this scale. We can make huge breakthroughs in medicine and research if we develop the proper tools. Since the nanoscale is so special, we want to take advantage of it. But let us first look at some reasons why nanoscale materials have such special behaviors as if they are drugs. So the first reason is that the surface area of materials increases significantly in the nanoscale. And to understand about this, we are diving into the game Minecraft. So have you ever seen these green slimy thingies that have life and move around? If you kill it, it will break into furthermore little pieces. Now you can see that the edges and corners that were not earlier exposed to the surroundings are now exposed. So its overall surface area has now increased. What am I doing? This was supposed to be a science video. Okay, coming back. Anyways, that was some time well spent. But do you know why chemists and scientists are excited about this increased surface area? Because due to this reason, nanoscale materials can act as excellent catalysts and speed up chemical reactions. And this includes the reactions taking place in industrial manufacturing processes and products. So it's getting a lot of attention, unlike this YouTube channel. So the point I was trying to make is that materials have larger surface areas in the nanoscale. So that is one of the reasons nanoscale materials have such unique properties. Another reason will make sense if you understand who is actually the boss in nanoscale. In our everyday life, classical physics seems to dominate everything, but in the nanoscale, quantum mechanics is the boss. Yep, classical physics has no control over this territory, so that's why the materials are behaving so shady. Isn't it amazing how we are so scientifically advanced that we are literally manipulating atoms and molecules? But how will we do this so-called manipulating atoms? Basically, there are two approaches. Let us look at the top-down approach first. This involves dealing with the material in the bulk or macro form. The top-down approach is essentially breaking down of the bulk material to get nano-sized particles. And this can be achieved by using advanced techniques such as precision engineering and lithography. The bottom-up approach refers to the buildup of nanostructures from the bottom itself, that is by atom or molecule by molecule. But to simplify things, self-assembly is the process by which atoms and molecules organize themselves into ordered nanostructures by the chemical or physical interactions between them. You cannot just shrink yourself to nanoscale dimensions like Ant-Man, so we have to use some specialized and powerful devices to do that. That's where the atomic force microscope comes in. These consists of a beam-like cantilever with a tiny tip which is typically used to scan a nanostructure. The tip is only a few nanometers in diameter. As the tip is brought close to the sample being examined, the cantilever moves because of the atomic forces between the tip and the surface of the sample. Atomic force microscopes and scanning tunneling microscopes allow researchers to create an image of an individual atom or molecule. And using that sensitive tip, researchers can also literally pick up and move atoms and molecules like they're tiny building blocks. So where is all this nanotechnology actually being used? I would love to say Iron Man armor, but no, priorities straight. But let's look at something quite related, nanorobots. One of the most exciting areas of nanotechnology is the possibility of building incredibly small machines. A machine has moving wheels, gears, and levers that have their own particular functions. But how do you make moving parts from something as tiny as a molecule? It turns out that there is a way to do it. Some molecules are regularly shaped and symmetrical, so they have no overall positive or negative charges. Other molecules are not symmetrical, which means they have slightly more positive charge at one end and slightly more negative charge at the other. These are called polar molecules, and water is the best known example. We can even use this idea to make a molecular machine. When I say nanorobots, it is very tempting to imagine pictures shown in science fiction movies. But in science, nanorobots are names given to molecules that perform a certain function. Who knows, one day maybe we would release thousands of these nanorobots in our bloodstream and they could be scanning for cancer tumors and destroying them in their infancy. Or maybe these nanorobots could even be destroying the world domination thoughts of my cat. The future is really very uncertain. I don't know about you, but Phil from Modern Family would become super excited on hearing all this. In the nanoscale, particles have a name. Any guesses? They are called nanoparticles. A nanoparticle is a small particle that ranges between 1 to 100 nanometers in size. Classical physics can't explain why these particles sometimes change color when they change in size. We need quantum mechanics to understand it. That is why nanoparticles are sometimes called as quantum dots. And then there is graphene, the current generation's cool kid of materials. Graphene is actually an allotrope of carbon, which means that it is one of many physical forms of carbon. Interestingly, it is only a two-dimensional material, so it only has length and breadth. It's like 100 times stronger than steel and also very flexible, so we can bend it to our wish without worrying about anything. It is also an excellent conductor of electricity. My bro is the full package. It is going to bring about a revolution in material science. We must be proud. And then there's the copycat, carbon nanotubes. If you consider graphene like a flat sheet and roll it like a shawarma, you will get carbon nanotubes. They possess similar properties like graphene, but are sometimes covered with fullerenes near the ends. So as I was saying, nanotechnology has tremendous potential in medicine to develop cancer drugs and help in targeted drug delivery. They can also be used to monitor our health. Nanotechnology also has the potential to develop better quality industrial materials and solar panels that are several times more efficient. Maybe they'll be used for increasing the number of transistors and in developing flexible electronics. Humans have a long history of polluting everything they touch. It seems as if our mere presence emits filth vibes. And we have gone too far when it comes to pollution, particularly polluting the ocean. You see, there are these things called microplastics and they don't decompose and just stay in the ocean. They're very small and cannot be cleaned by conventional methods. Maybe nanotechnology will be our last hope to clean all that up. Nanoscale materials are also being incorporated into a variety of personal care products to improve performance. Nanoscale titanium dioxide and zinc oxide have been used for years in sunscreens to provide protection from the sun. while appearing invisible on the skin. All this sounds great and all, but the reality is that nanotechnology is very much in its initial research stages. In this video, I discussed only the positives. There can also be a dark future. Maybe some explosion happens in a science lab and now undetectable evil nanorobots take over the world and make everyone wear short clothes in cold winter days. No one knows. All I'm saying is, if these nanomaterials, which we know very little about as of now, are used on everything from cell phones to airplanes, we won't be knowing how much of an impact they'll create on us and our environment. So we have to be very useful and careful before using them. In this video, we saw how the smallest things can have a huge impact. It's kind of the same when you subscribe to this channel and turn on the notifications. It might be insignificant for you, but it sure brings a smile on my face. And as always, the choice is yours. You can check out my other content if you're interested in quantum computers or the possibility of reading other people's thoughts. And I'll see you later.